Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 42nd question of the problem solving series and the second question of stack data structure. The question has the difficulty level for this question is medium, and this question has been asked in Microsoft, Adobe, Flipkart, Amazon and many other companies. In fact, this question was asked to me in my last interview in Microsoft. I could do this, but I was rejected in the last round, uh, the HLD round. After 4 rounds, I was rejected. But yeah, I had a great experience, and this question was asked. This question was not asked directly. The question was changed, but the intuition and the logic was exactly as same to this question. So let's discuss this. Next greater element. So we are given an array of elements, and we need to return the array, but we need to return the next greater element of every element in the array. So what is next greater element? For example, this one. In this question, if we traverse the array, so for this one, the first element, the element which is just greater to this in the rightmost direction of it. So so from 1 we go to 3, and 3 is just greater than 1. So we will be so for this element, this position we will be having 3. So for 3, what is the next greater element in the right direction? 2 is not the next greater element. 4 is the next greater element for 3. So here we will have 4. And for 2, what is the next greater element? 4. And for 4, what is the next greater element? We don't have any elements towards its right. So what would be the answer? So if we don't have any next greater element for the element in the array, so we'll get right -1 in its position. So this would be the answer. So for this example, what would be the answer? What is the next greater element of 6? 8. What is the next greater element of 8? There is no next greater element of 8 in the right direction. So we will have -1 for 8. For 0, the next greater is 1. For 1, the next greater is 3. And for 3, we don't have any next greater element. So this is -1. So how do we solve this? How do we find the next greater element every time for all the elements in its right direction? We search the next greater element towards the right. It's given in the question. So yeah, what could be the intuition? What data structure should we use? So let's discuss the intuition first. So when we are going towards when we are traversing the array, and when we want to find the next greater element for the element, so we go to the right side and we see, okay, if it is just greater than this element or not. Say either if it is just greater than this element, so we need to store it. Okay, for this position, the 0th position, the next greater element is its first position. Okay, where do we store it? We can store it in a map, we can store it anywhere, right? So and then we can traverse it. Say we are assume that we store this in a map. Okay, so for 0 we have 1, the first element. Okay, and now, or we can even store the value for 1, the next greater element is 3. Now when we go to 3, we need to find. So for 1, we got the next greater element. Now we need to go to 3, right? So for 3, what is the next greater element? We need to traverse again. So if we traverse it again for 3, we need to find the next greater element. So 2 is not the next greater element. So we need to traverse again. So we see 4 is the next greater element, right? But we need to have this 3, right? So where do we store that value, right? So for 3, for example, 3, 2 is not there. So 4 is 4 there. So we have this 3. For 3 we store 4. Okay, 4 is the next greater element for 3. For the position, because the numbers can be repeated, right? 3 can be again here. So it's better to store the position. So the 0, 1, 2, 3 we store. Okay, for 1, the third position is the element, right? Then we go to 2. For 2, the next greater element is 4. So 2 for 2 we will have 3, and for 3 we will have 1 -1. And then we go to traverse this map and we see, okay, these are the elements. We take a new array and we can insert the elements in this direction. We can do it, right? it would take order of n for traversing. If it won't take order of n, it would take order of n square, because we need to find it every time. From here to here we'll go here. Okay, so it would be increasing. We are not doing it in a single traversal. So to know the elements, right? So for example, for 1, if we have the answer, okay, say 4 is the answer. So say 3 is the answer, right? If this is for 1, 3 is the answer. For 3, 4 is the answer. But for 2 also 4 is the answer. So for 3, when we are in 3, when we see that okay, 2 is lesser than 3. So for 3, when we find okay, 4 is the answer for 3, it's obvious that for 2, the same number would be the greater element for 2, right? Not necessarily, right? Not necessarily. If suppose it's 5 and it's 2 and 4, so for 2 it won't be 5, okay. But we need to store, right? We don't need to keep on checking it every time. So if we have a stack data structure, which is a last in first out data structure. So if we use a stack, say for example, let's solve the problem. This got solved using multiple traversal, right? We need to we went from 2 to 4 again. For 3 we went to 4, and then again 2 we went to 4. Okay, so 2 we had to go back again, right? So it takes multiple like a double loop probably. But if we take a stack and then say we traverse the array, 6 is the element. Okay, so first element we don't have, we put it into the stack. Okay, now 8. So we go to the 8. Okay, and then we know what do. We always compare the next element to the element which is there in the stack. So we put the first element into the stack, and then now we have 8. We see 8 is 8 greater than the top element in the stack. Yes, it is greater than top element in the stack. So we have this stored. Okay, for 6, 0th, we have the first element. Okay, 0, 1, 2, 3, 4. Now we go. So once we have this, okay, for 6 we have got the value. Just remove the 6, right? We have got the greater element for 6. We insert 8. Now for 8, now we go to the next element. We can just check the stack, the top element of the stack, because in the stack we have all those elements whose next greater element we don't have. So for 0, when we are in 0 again, so from 8 we traverse to 0. We see what is the next greater element for 8. What is the next element in the stack? 8. Is 8 greater than 0? No. So what do? We insert 0 in the stack. Okay. Now we go to 1. We see what is the next element? 0. So we understood that we know that 0 is greater than 1. That means actually we need to insert the position, right? That would be better. So this is the first position and this is the second position, right? So now when we for 1, when we check, we pop this out and we see okay, 0 is greater than 1. So for second, the third element is the answer. So we pop this out. And then what do? We have another element which could be a lesser than this. It could be a greater next greater element for this. So we see, is this element 8 greater than 1? 8 is 1 greater than 8? No, it's not. So we can't remove this. We will put this element also, 3, because this is not its greater next greater element. Now we have 3. So now we pop it out, the stack, we check with 1. Okay, so this 1 is less than 3, right? So we know that for the third element, the next greater element is for fourth position element, and this will be popped out because we have the answer. And now we insert this position here. So we know the answer. Okay, for 0 element, the first element is the next greater. For second, the third is the fourth is the next greater element. Now in this case, when we didn't know what is the answer, we had to like insert -1 every time after checking the whole thing, right? But here we just see the stack. What are the elements whose next greater element we couldn't find? So these are the elements. So stack is not empty. So for the fourth position, it would be -1. The value answer would be -1, and for the first position, the value would be -1, right? So and then we can just traverse this and add it into a new array, or But what would that, if we do that, so then there would be extra space. We are taking extra space of a map where we are storing the position. Can we reduce this extra space and use the same array for it? Then anyway, the time complexity would be order of n, right? We are traversing it once using stack. The space complexity, can it be order of 1? Order of n, of course, because we are taking the stack. But can we reduce one extra map by using the same array? Let's see, let's try. What can we do? I'll explain the code meanwhile. So what do? We take a stack int st, say, and we have n is equal to array dot size, the number of elements. Okay. Now for I equal to 0 to n, right? So if the stack is empty, what do? The stack is empty, we just push the element. Okay. What do we push? We will push the position. Okay, position of the element in the stack, not the element. And then we push this and we'll continue this. Okay, we don't need to go and see the other code. We will again go to the next element. Okay, this is the part. If the stack is empty, we will do this much operation only. Otherwise, else. If otherwise the stack is not empty, right? Then what do? We check if stack is not empty. Stack is not empty, and if stack, the topmost element, the last inserted element in the stack, if it is less than the current element that we are traversing, what does this mean? This means, for example, here this 8 was greater than, we inserted 6, right? We inserted 0, and then we see that 8 is greater than this. So what do? We store this, right, 0 to 1, okay, in a map. So instead of storing it in a map, can we store it here itself, in the array itself? What do? So array stack dot top was the position, right? And here for this the value should be array of I, right? And we are not going to traverse this element again, the first element, right, the 0th element. So here only we have changed the value, right? Okay. So the 6 has become 8 here only in the first step. And then what we do? We need to pop this element, st dot pop, the first inserted element. Okay. But if there are more such elements, like for example 8 and 0, right? So there could be more elements, right, which could be lesser than this array, right? Say here, for example, here when we insert 8 into the stack, the first position, then 0 came. We inserted 0 as well in the stack because this was not, so we inserted 0, right? So we will push the element anyways. After we are done, we are pushing the position, right? But when we got 1, then we checked with 0, okay, if it is greater. Then we made this position, but then again we need to check for 8. So instead of else if, we will be doing while and keep on assigning the elements till all the elements, if the stack dot top is lesser than the current element we are there. So for all those elements that are there in the stack, this will be the next greater element till this condition is satisfied and till the stack is not empty. I hope you got my point, okay? So once this is done and we see, okay, say for example, so once this is done, for example, for 0, 1, for 3 we don't have anything, we insert every time in whatever element we are there, we need to find its next greater element. So we'll insert that position, not that element, the position of that element into the stack, and then we can just check by checking it as array stack.top and compare, right? So this should not be stack.top, this should be array of stack.top, right? Stack.top is the position, so it would be array of stack.top, right? So we inserted this and we have modified it. Now this is done. We've traversed this. Now we see while, so stack my main will not be empty. While stack not stack dot empty. What do? We insert okay. So array of stack dot top will be -1 because there is no next greater element for that, and then we'll pop them so that all the elements get their next greater element, and then we return the same array. Okay. I hope the explanation is clear, the code is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 42nd question, next greater element in Gigs for Gigs platform in C++ language. As you can see, these are the same examples that we have discussed. You can see here, if it does not exist, the next greater element for the current element is -1. Okay. So let's look at the code. We have the vector of a long data type array, and the size of the array is also given, and so we are traversing this, and we are using the same logic. Array of I is greater than array of st.top. We are doing the same thing as discussed. Okay, so I'll just compile and run this. So the expected output matches my output. So let's submit this. See, so it has passed all the test cases, and yeah, solved it. I hope this explanation has been very clear to all of you. So see you all soon in the next video, where I'll be explaining the 43rd question of the problem solving series and the third question of the stack. Jai Jinendra.